Your first Google Cloud code. Now that we have a better understanding of Google Cloud and its capabilities, we can begin creating our serverless application using Google Functions. So the first code will use Google Function. If you already have the project, SDK, billing, and API set up, you can proceed to the Hello World section. If not, please take the 5 minutes to set these up. To set the project, go to project page shown in this link. Create a new Hello World project in this space. We will also need to enable billing. Take the following steps to do this. From the project list, select the project re-enable billing for open the console left side menu and select billing. Click link a billing account and click set account. Next, we want to enable Cloud Functions API. From the projects list, select the project or create a new one. If the API manager isn't already open the console left side menu and select the API manager and then select library, click Cloud Functions API, click enable. You can install the Google Cloud SDK by downloading the correct package from here. https://cloud.google.com/sdk/docs. At this point, you should have all the prerequisites in place to begin developing our serverless application. Hello World. We will start by creating a new function in the Cloud Functions console. To get here, navigate to Cloud Functions from the dashboard, as shown in figure 510. We will create a new function, name it Hello World, and give it the following properties: name, region, memory, timeout, trigger bucket. The name is Hello World, the region is US Central 1, memory allocated 128 megabytes, timeout 60 seconds, trigger HTTP trigger, bucket Hello World, as shown here. We are going to select an HTTP trigger to make this a base function for our HTTP trigger function. Google is similar to Azure in that it provides you with the URL to access and trigger your HTTP functions. So you can do that through a URL. With this, we can test and run our function without having to stand up an entire API. Configuration for any function requires a name, trigger, region, memory, timeout, source code, and source bucket. Names do not have to be unique universally, just within your functions. Google Cloud is also give you the choice of editing your code inline or uploading a zip file. Since this function is going to be simple and small, we can edit it inline. And here is the function, and here is the execution of it. This function returns an output equal to the input and send us log detailing the trigger. The function should trigger an output very similar to the input and should also trigger logging for the function. If you grab the URL for the function and copy it into Postman with a request, you should get the same result, just like that. Postman post request to our Hello World function. Now we are going to look at stack driver logging. This is helpful for debugging and for the construction of our function. Stack logging. Stack driver logging. Stack driver logging. Stack driver logging allows us to store, search, analyze, monitor, and alert on log data and events from Google Cloud Platform and AWS. I actually haven't used this with AWS yet, but the integration is an important step. A lot of companies fear transition to cloud due to vendor lock-in. It means you cannot move away from the vendor, right? Providers that embrace this fear and provide solutions for it are making the right move by being more integrated. Stack Driver API takes any log data from any source. This is great because it allows analysis of this log data in real time. Stackdriver's login includes these features: custom logs, ingestion API, AWS integration agent, log retention, log search, log-based metrics, log alerting, advanced analytics, and BigQuery, archive with the cloud storage, stream log with the cloud PubSub, Spring and login trees integration, audit logging. All this is provided by Stackdriver logging. Stackdriver API takes any log data from any source. Stackdriver remind me a lot of CloudWatch in AWS. AWS provides option to send CloudWatch logs into Elasticsearch. This gives you a lot of the same features we are looking in Google Cloud Stackdriver. Figure 513 will give you a better idea of how Stackdriver logging works. And here is the figure. So here it shows Google Cloud Platform, and here is Stackdriver logging, and it shows here. Stackdriver gives you access to metrics, exports of logging, and logging on a function of a particular date. Stackdriver Debugger lets you inspect the state of an application at any code location without stopping or slowing it down. To give an example of how we could use the debugger, I'm going to go to the console and enable the debugger to access my GitHub. GitHub will ask you to grant Google Cloud access to your repo. When I do this, you can select a source from your repo that you want to look at. I have been working on Alexa Skills project with some coworkers, so I'm going to open that repo up and take a look. Feel free to explore some of your own code. Your users are not impacted during debugging. Using the production debugger, you can capture the local variables and call stack and link it back to a specific line location in your source code. You can use this to analyze the production state of your application and understand the behavior of your code in production. Stackdriver lets you look at a production code in debugging mode. Right? Stage bucket. Google Cloud uses the idea of a stage bucket to stage and deploy your code in Google Cloud. We will look more into buckets during the creation of our storage trigger function, but it will be useful to see a high-level overview now. So this will be a high-level overview of something called stage bucket that will be used in the next example, that is storage trigger function. What is stage bucket? In Google, the buckets resource represents a bucket in Google Cloud Storage. There is one global name shared by all buckets. This means every bucket name must be unique. Buckets, figure 516, contain objects which can be accessed by their own methods. In addition to the ACL property, buckets contains bucket access control for use in fine-grained manipulation of existing buckets access control. A bucket is always owned by the project team owners group. So bucket 516. The storage bucket for my cloud function. So this is the cloud, Google Cloud Platform, and this is the storage. And it's called storage bucket. This is where our cloud function code is being stored. You can access it from the bucket. You can also create, upload files and upload folders. This interface is very similar to AWS S3 for me. It is very simple to use, easy to understand, and easy to access. Before continuing to our HTTP event trigger function, we are going to add a couple of things to our hello world function. Request parameters that we should learn include request.method, request.get, request.query.foo, request.body.text. We are going to elaborate our hello world function so it is able to handle different types of requests. We will use the request.method parameter to specify which action to take in which case. The code in listing 5.1 demonstrates how to handle this, and here is the 5.1 listing. In this code, and here's the rest of it. In this code, we are changing our response based on request type. You should be able to see these results in Postman. You can see how we'll be able to use this in our advantage later on. Within serverless architecture, it is usually better practice to separate these requests from each other in the code. For this, you could have a cloud function for each request that handles one execution. We can still use the request.method property here in our more singular functions to double check that the requests coming in are valid. It is also important to know the structure of the request coming in. The body of the request is automatically parsed based on the content type and populated in the body of the request project. Figure 517 demonstrates the request types that Google accepts. Request bodies for various content types. Application JSON, name John, behavior request.body.name equals John. Application octet stream my text request body equals to c.node.js buffer docs. Text plain my text request body equals my text. Application xww from URL encoded equals John. We can test the different request bodies using switch statement, similar to the ones we wrote to determine the method inside our post and get functions. We will include a switch statement that looks for the content type and returns the appropriate response. The following code demonstrates this. And here's the code. If we test this in Postman using a put request with a JSON object, we should receive the response defined in the handle put under the application JSON content type, figure 518, which is this one here. Now that we have a basic understanding of handling requests and responses in Google Cloud Functions, we can move on creating a more full-fledged HTTP trigger function. HTTP event. Our HTTP trigger function is going to utilize several components of Google Cloud to create notification system. For the HTTP event, we will utilize a post request and a Firebase real-time database. Again, for the HTTP event, we will utilize a post request and a Firebase real-time database. So there is a database that's real-time, and it's called Firebase, and it's from Google. I'm currently working on an Alexa skills project that creates requests for guests from their hotel room. I'm going to base the functionality of this function on that system. Our application is going to take an incoming post request with a room number and service request and post it to a database. Our HTTP event will handle post request with the new guest information and will add the information to a guest storage bucket. The storage function will then be triggered by this object upload and will integrate with Firebase to notify the guest. Shows the plan for the overall architecture of the next couple of exercises. So here is the post request from phone number, and here's the function, here's the database, here's the function, and here's a new message. The post request will take a room number and add a guest data to it in the database. To start, we'll go ahead and create another HTTP trigger function. So we are going to create another HTTP function. I choose to create a new storage bucket just to keep all function services together. I also change the function to execute to HTTP trigger and change this the sample code as well. Figure 520 shows what my new functions configuration should look like. Before we continue developing this skeleton of a function, we are going to set up our Firebase environment. In this aspect of the project, we will use Firebase to create a database and integrate it with our cloud function. To connect a Firebase housing, we will need to set up cloud functions, write our function, create rewrite rule, and deploy our changes. Firebase real-time database. The Firebase real-time database is a cloud-hosted database. Data is stored as JSON and synchronized in real time to every connected client. This is perfect for our use case because we can just store JSON objects of guest and room numbers. When you build cross-platform apps with our iOS, Android, and JavaScript SDK, all of your clients share one real-time database instance automatically receive updates with the newest data. Some applications of the Google Firebase include serving dynamic content, pre-rendering for SPA to improve SEO, lightweighted web apps. Firebase and Google Cloud are pretty integrated with one another and share a lot of the same resources and functionality. While Firebase is primarily for mobile apps, you can use the scalable and infrastructure-free aspect of it to quickly set up and deploy serverless applications. You can later integrate these applications with mobile platforms to continue running them as is. So Firebase is primarily for mobile apps. Google Firebase is primarily for mobile apps. You can install the latest version of Firebase CLI by running the following command in your terminal: npm space install space -g space firebase -tools. This will install the Firebase toolkits on your terminal. We're going to use this to access Firebase projects and deploy it using Cloud Function. It has a similar functionality to Serverless framework in this regard. Firebase. Firebase provides you with a URL to log in to your Google Cloud account. This will allow you to deploy to your cloud environment directly. Once you are authorized, you can begin initializing Firebase projects in the current directory. However, before doing this, you will need to return to Firebase console and create an existing project with hosting. To do this, navigate to console.firebase.google.com. Click Create a New Project and name it HTTP Project. Figure 522, as shown here, shows that the new project. After creating a project, you can initialize it back in our terminal with the command fire space use space add -add. This will prompt you to select your project and create an alias for it. Go ahead and select project created. I choose staging as my alias, but feel free to name yours as you please. After this, we have an existing project with hosting and can run the following command within our project directly to initialize cloud functions. And here's the command: Firebase space init, just like initialize, space functions. This command does a couple of things. First, it creates a function directly within an index.js file. This is your cloud function file that we will be editing. Second, the command adds a .firebase rc file to your project directly. This file is where your alias definition are written. We don't need to change it, but feel free to take a look and see how the alias is defined. Mine looks like the following, and here's how it looks like. Finally, the init or the initialize command creates a firebase.json file. This file is the configuration file for our current directory. We are going to use this file to handle rewrites within our function. Rewrites aren't really necessary for our application, but we will go through an example of using them just to be comfortable with them. With rewrite rules, we can direct requests that match specific patterns to a single destination. CORS stands for Cross-Origin Resource Sharing. Cross-Origin Resource Sharing. Enabling CORS allows resources to be accessed from another domain outside the domain from which the first resource was served. The code takes the incoming request and separates it based on its query. It returns the request to the user in HTML format. We will also want to edit our firebase.json file to redirect our request based on the method. The following code is how I choose to redirect my function. This specifies the folder that our project is pulling from, the source we want our request to be directed to, and the name of the function we want to execute. To deploy this function, we will use the firebase deploy command in our root directory. Once your code has successfully deployed, we can test the functionality by simply hitting the function's URL in our browser. To do this, enter the following URL with your request. This will submit request to your function that you created and return response you specified. Right. Obviously, this isn't the most glamorous way to display our information in the browser, but it still gives you a feel of how Cloud Function integrates with Firebase and the different applications to this integration. You can also access this request in Postman Figure 525. You can take the query string and make them a part of the body of the request to test the different ways to access our information. In this exercise, we have used Cloud Functions with Firebase to deploy an application that takes an incoming post request presented in the browser and submit it to Firebase real-time database. Now that we know our function is being triggered, let us do something real with the information coming in. We are going to build off our current serverless function to allow the data coming in to be stored in a Firebase real-time database. To do this, we are going to edit our function to connect to a database that we name and push each incoming entry into that database. The following code demonstrates this concept in action. And here's the code. And here's more code. The real-time database is now a SQL database and such has different optimization and functionality than relational database. The real-time database API is designed to allow only operations that can be executed quickly. This enables us to build a great real-time experience that can serve millions of users without compromising on responsiveness. As you can see in this code, we are first checking the incoming request parameters to see if the request is coming in through the query string or a JSON body. We then parse the request and fill it to the alerts path in the real-time database from our project. Once you have this code fleshed out, we can go ahead and redeploy it to our application. We will use the same Firebase deploy command. If we navigate back to the Firebase portal on the left side, we will see a database option. Clicking it will take you to the database console with the real-time data. You should see a structured data table under the name of your project. Below the project name, you will see any path you have created and the data associated with each. My data panel looks like the figure 526, which is this one here. The alert and room number are associated with the particular key that is generated upon the request. You can add as many properties as you like, and they would change dynamically with the request. The Firebase real-time database data is stored as JSON objects. Google likes to describe the structure as a cloud-hosted JSON tree. Unlike SQL, there are no tables or records. All data are added simply become a new node in the existing JSON structure with an associated key. You do have the ability to provide your own keys in your post request. Google also recommends several best practices for structuring your data, which we will look at next.